Welcome back. I'm Luna with the International School of Forecasting. In episode 1, we covered the fundamental problem that every ancient civilization faced. The solar year and the lunar month don't align. The Romans tried twice to create a working calendar, and twice they failed. Romulus's 10-month system left 61 days completely untracked. Numa's 12-month system drifted 10 days per year. For centuries, Rome lived with this broken system. Politicians would arbitrarily add or remove days to manipulate the calendar for their own purposes, extending their terms in office or shortening their opponents' terms. By 45 BCE, the calendar was months ahead of the actual seasons. Planting times were completely off. Religious festivals happened at the wrong time. It was chaos. Enter Julius Caesar. Julius Caesar didn't just tweak the calendar. He made a radical philosophical decision that would shape timekeeping for the next 2,000 years. He said, "We are abandoning the moon. We're going pure solar." This was a massive shift. For thousands of years, calendars had tried to honor both the sun and the moon. Cultures around the world used lunisolar systems that added extra months periodically to keep lunar cycles aligned with solar seasons. Caesar said, "Pick one. We pick the sun. Seasons matter. Moon phases don't matter for civil purposes." In 45 BCE, Caesar introduced the Julian calendar. Here's how it worked. 365 days per year normally. Every fourth year is a leap year with 366 days. The extra day goes in February, making it 29 days instead of 28. 12 months with new standardized day counts. The months were restructured like this. January equals 31 days, February equals 28 days, 29 in leap years, March 31 days, April 30 days, May 31 days, June 30 days, July 31 days, renamed from Quintilis after Julius himself, August 31 days, later renamed from Sextilis after Augustus Caesar, September 30 days, October 31 days, November 30 days, December 31 days. Total 365 days normally, 366 in leap years. The Julian leap year rule was simple. Every year divisible by 4 is a leap year. That's it. No complicated exceptions, just divide by 4. If it divides evenly, add a day. Why does this work? Because the solar year is approximately 365.25 days. Not exactly 365, but 365 and a quarter. So if you have 3 normal 365-day years, then one 366-day year, the average works out to 365.25 days per year on average. The real solar year, the time it actually takes Earth to orbit the sun, is 365.2422 days. So Caesar's system gives us 365.25 days. The error is 365.25 minus 365.2422, which equals 0.0078 days per year. That's about 11 minutes per year. Doesn't sound like much, right? But here's what happens over time. 11 minutes per year multiplied by 400 years equals 3.12 days of drift. By the year 1200 CE, the Julian calendar had drifted 7 to 8 days from the actual solar year. Caesar couldn't have known this. The math required to measure the solar year that precisely didn't exist yet. For his time, the Julian calendar was remarkably accurate and a massive improvement over what came before. Caesar wasn't just fixing math. He was consolidating power. He moved the year start from March to January. Why? January was named after Janus, the god of beginnings, yes. But more importantly, January was when Roman magistrates took office. By making January the start of the year, Caesar centralized power around the new year transition. The calendar became a political tool. He also renamed months after himself and his successor. Quintilis, the 5th month, became Julius, July. Sextilis, the 6th month, became Augustus, named after Caesar's heir. The calendar was no longer just about tracking seasons. It was about projecting imperial power. This is important to understand when people claim that calendar changes were all about spiritual suppression or religious control. Politics and power have always been part of timekeeping. For 1600 years, the Julian calendar was the calendar throughout the Roman Empire and eventually throughout Christian Europe. It was adopted as the standard. It worked well enough for agriculture, it worked for governance, it worked for religious observance. But that 11-minute error kept accumulating. Before we get to Pope Gregory's fix, we need to understand something about seasons that most people don't know. This will help explain why calendar design is so complicated. Most people think Earth orbits the sun in a perfect circle. It doesn't. Earth's orbit is elliptical, oval-shaped. At one end of the ellipse, Earth is closest to the sun. We call this point perihelion. At the other end, Earth is farthest from the sun. We call this aphelion. Here are the actual distances. Perihelion, closest to sun, about 147.1 million kilometers. This occurs around January 3rd or 4th every year. Aphelion, farthest from sun, about 152.1 million kilometers. This occurs around July 3rd or 4th every year. The difference is about 5 million kilometers, but this creates a measurable effect described by Kepler's second law of planetary motion. Kepler's second law states that a line segment joining a planet and the sun sweeps out equal areas during equal intervals of time. Translation: when Earth is closer to the sun, it moves faster. When Earth is farther from the sun, it moves slower. The actual speeds are, when Earth is at perihelion in January, about 30.3 kilometers per second. When Earth is at aphelion in July, about 29.3 kilometers per second. The difference is about 1 kilometer per second. Earth moves faster in winter and slower in summer. This affects season length. A season is the time from one solstice or equinox to the next. There are 4 turning points each year. 1. Vernal equinox, spring begins, around March 20th or 21st, sun at 0 degrees Aries. 2. Summer solstice, summer begins, around June 20th or 21st, sun at 0 degrees Cancer. 3. Autumn equinox, autumn begins, around September 22nd or 23rd, sun at 0 degrees Libra. 4. Winter solstice, winter begins, around December 21st or 22nd, sun at 0 degrees Capricorn. Here are the actual season lengths in 2025 for the Northern Hemisphere. Spring, March 20th to June 20th, 92.75 days. Summer, June 20th to September 22nd, 93.65 days, the longest season. Autumn, September 22nd to December 21st, 89.85 days. Winter, December 21st to March 20th, 89.99 days, the shortest season. Total, 365.24 days, which matches the solar year. The difference between the longest season and the shortest season is 4.66 days, almost 5 days. Why does this matter for calendars? Because you cannot divide the year into 4 equal seasons. Real seasons are 89 to 94 days, not 91.3 days each. You cannot divide 365 days into 12 equal months. 365 divided by 12 equals 30.4 days, not a whole number. This is why calendar designers have to make compromises. They can't create perfect mathematical alignment between the solar year, the seasons, and the months. The universe doesn't cooperate with neat human divisions. By 1582, the Julian calendar had drifted nearly 13 days from the astronomical year. The vernal equinox, which should fall on March 21st, was actually occurring on March 11th, 10 days early. Now, why did this matter? Because the Catholic Church calculated Easter using the lunar cycle, and the formula depends on the vernal equinox falling on March 21st. Easter calculations were wrong. Easter was falling at the wrong time. The Church couldn't tolerate this. Pope Gregory XIII issued a papal bull in 1582 with 2 orders. First, skip 10 days immediately. October 4th, 1582, was followed by October 15th, 1582. Days October 5th through 14th simply didn't exist. This corrected the accumulated drift instantly. Second, refine the leap year rule to prevent future drift. The new rule is more complex, but it's brilliant. Keep the divide by 4 rule. Years divisible by 4 are leap years, but years divisible by 100 are not leap years. Except years divisible by 400 are leap years. Let's see how this works with examples. 2024, divisible by 4, but not by 100. Leap year, 366 days. 2025, not divisible by 4, not a leap year, 365 days. 1900, divisible by 4 and by 100, but not by 400, not a leap year, 365 days. 2000, divisible by 4, by 100, and by 400, leap year, 366 days. In 400 years under the Gregorian calendar, years divisible by 4, 100 years. These would all be leap years under the Julian calendar. Years divisible by 100, 4 years. Remove these from leap years. Years divisible by 400, 1 year. Add this back in as a leap year. Net leap years is 100 minus 4 plus 1 equals 97 leap years in 400 years. Total days in 400 years, 365 days times 303 normal years equals 110,595 days, plus 366 days times 97 leap years equals 35,502 days. Grand total, 146,097 days. Average per year, 146,097 divided by 400 equals 365.2425 days. The real solar year is 365.222 days. Error is 0.0003 days per year. Over 400 years, the drift is only 0.12 days. The calendar drifts only 1 day every 3,333 years. This is accurate enough for any practical purpose. Pope Gregory's refinement took the Julian calendar's 11-minute error and reduced it to less than half a minute per year. Brilliant. Catholic countries switched to the Gregorian calendar immediately in 1582. Protestant countries resisted for decades or even centuries, refusing to follow a papal decree on principle. Britain and America didn't switch until 1752, 170 years later. Japan, 1873. China, 1911. Soviet Union, 1918. Eastern Orthodox countries not until the 1940s. But eventually, global trade and international commerce forced adoption. You can't do business across borders if everyone's using different calendars. Dates on contracts need to mean the same thing everywhere. The Gregorian calendar is now the universal civil standard for the entire world, not because it's the only correct way to measure time, but because everyone agreed on it. The evolution from Romulus to Numa to Caesar to Gregory shows us something important. Calendars are designed tools. They're not cosmic truth handed down from the universe. They're human solutions to the problem of coordinating activity across large groups of people. Each change was made for specific reasons: fixing drift, improving agricultural planning, consolidating political power, aligning religious observances. Understanding these reasons helps us see through modern conspiracy claims about calendars being deliberately designed to disconnect us from nature or suppress spiritual knowledge. In episode 3, we're going to tackle the 13-month calendar myth head on. We'll look at the actual mathematics, the real lunar cycles, and why the claims you've seen in viral videos don't hold up to scrutiny. Thanks for listening. I'm Luna, and I'll see you in episode 3.